Hello guys, welcome back. In this CCNA video tutorial, we are going to discuss today about EIGRP routing protocol. In this lab, we will discuss small theory about EIGRP. Then we will discuss more about, we will configure the what is the small theory about design consideration. Then we will jump onto the configure of the EIGRP. Okay, so EIGRP is a proprietary protocol for the Cisco's. So they submitted for open source, but IETF is rejected it. But some part of the EIGRP protocol is open source now. Okay, and other thing about what is the advantage and EIGRP protocol what is advantages and feature does it has actually. The main advantages of the EIGRP, it do not have any limitations, like you can you can change your topology however you want. Uh, you can extend your network topology. You don't need to consider about like areas, or every area need to connect something area backbone like OSPF. But the other thing is it has a weakness also. We will discuss that later in this same video. Okay, and also the main advantage, it will incremental updates. Periodically it sends hello to neighborship routers, but only sends updates when a change occurs, when the route is added to the new route added to the router, or any withdrawn. Okay, and the other one is uh, it's a rapid changes. It won't takes lots of time to establish the old topology of the from one area to the another area connection. Like OSPF will build old network topology to do that. But EIGRP will take, if for 1000 routes it takes only 120 milliseconds. So that much speed that EIGRP takes. But if it's a big organization, sometimes you have 10,000 routes from one point to another point. So that is a different problem. That's another issue it has. We will discuss that one. Okay. And what is the best feature is the same like OSPF. EIGRP also used one reserved class D IP address to send multicast and everything. Okay. So uh, if we send multicast and it's sent using the 224.0.0.10. Okay, that's the one. We have the features and advantages. Okay, and what are other things we will get it from this one? EIGRP is about the, it will looks for the bandwidth, and it neighbor discovery is more quicker than the OSPF, but there is also some disadvantages we will discuss in the next thing. Okay, and what are the design consideration, like that means what are the issues we have with EIGRP. So main issues is scaling an organizational network. I said that is a very good strength of that EIGRP, but that is also weakness of EIGRP. What it will do, when the network has grown including hundreds of routers, and when route is lost, EIGRP may send out query message to the neighbors. So when, if it's, I explained that if it's 10,000 routes there, so it more net routers will be, the routers float this out to each neighbor next to the each neighbor. So that flood all the network. So that is also another one consideration when you're designing that. To rectify that one, you can do different autonomous systems. Okay. And another thing is, when this when is flood network with the advertisements next to the neighbors, so this is very big problem in WAN links. Uh, the network won't, the latency will increase automatically, so it will become saturated. Okay, the another thing is, to mitigate that issue, we had a summarization on EIGRP. But when you summarize the route, That is the big another problem we got. When you summarize the root of the in EIGRP, it won't send complete information to the routers. So that is very less information you will receive about summarization and the speeds of the links. So it won't make decision to quickest route EIGRP. If you summarize the route, it won't make good decisions depend on the cost or depend on the administrative distance from the one router to the another route. So that's another disadvantage. So that's why you can't go with summarization and also you can't go with speed together. So you will get only one benefit on that. So that is some of the design consideration I explained. Okay, I'm not going to bore you about everything whatever the EIGRP. We will jump onto our network. So we will configure the EIGRP and the network now. Okay, here is our network. Is a six two paths to from PC1 to PC2. So we are using 6 routers here, but the the thing is I'm not going to do everything in the video now. I just do one route now, and I will pause the video. I will configure remaining routes, but none of the one is not configured anything at the moment. It's a completely blank one. Okay, so I will configure one route first. Now I will configure route one. So why I'm configuring route one, it is connected to this one and this one, and that's why I will discuss that one. Yeah. Oh, sorry, we will configure route 6. So why it has a host connection. It has a one path to it has two paths to PC2. So I will configure route 6 in the beginning of this one. Then I will explain that which route it will taking. How can we stop to take the another route if you want to change that in increase you forcing the router to take the another path. Okay, so if I go into the console here, these are the routes not configure anything. So I am using iOS software, Cisco iOS V virtual iOS. So you can see that everything iOS V is strictly limited for evolution. Please buy on the Cisco website using VIRL images. Okay, I'm configuring host name now. Host name is config t host name R6. Okay, then we will configure the network IP addresses for this one. What we between these two protocols, I am going to use 192.168.100/30. Okay, so we need only two IP addresses on each node. So so if I /30, so I will get lots of networks. So we don't need to worry about anything. So I will use the same network, same class network, all the nodes. Okay, so interface. Sorry, we will display the interfaces is not viewing. So show hidden interfaces. Okay, it's easy to configure. Okay, interface gigabit ethernet 00 now. Okay, gig 00. Okay, IP address ADDRESS IP address. I'm starting from 192.168.100.1 on 00 interface. Okay, so we will use that network 255.255.255.252. So we are getting only two hosts address from that network, and remaining is networks going to the next bits. Okay, so each network got two host addresses, so 252 and no shut. Okay, that's it. We configured interface on 00, and then we are configured the 01. Okay, interface gig is 0/1. Okay, and IP address, we will take this one 192.168.100. We take 4 network. In the .4 network, first available address is .5. Okay, then 255.255.255.0 252. Okay, that's it. No shut. Okay, I configure the both interfaces. Then we have the another interface is gigabit Ethernet is 02. Okay, what we will configure is interface 19 sorry, interface gig is 02 inter sorry, I spell mistake. Okay, IP address 192.168. I'm configuring 1.1 on that interface and 255.255.255.0. Okay, and no shut. Okay, this is our default gateway for PC1 also. Okay, so I configure those interfaces now. Okay, I'm pausing the video. I'm going to configure all the interfaces in the network on all the routers. Then I come back. Then we will configure EIGRP. Okay, see you after some time. Okay, guys, I configured all the routers with the IP address, and we haven't configured any routing protocol at the moment. So if I go here route 6, you will see that do show IP interface brief. Yeah, so you will see that I just configure all the interfaces as I marked down in the network. Okay, so if you show the do show IP route, sorry, routing protocol or routing. Sorry guys, do show run. Okay, if you see the run, you haven't find any routing protocol. We haven't configured anything yet. Okay, here is the only just interfaces you configured. Okay, that's it. Okay, this is auxiliary. This is about the login information and console configuration only. Okay, now we are going to configure our EIGRP and step by step for next step. Okay, first thing router 6 we will choose. There is two types we can configure the EIGRP. One with a wildcard, wildcard or without wildcard. If you configure without wildcard, it will summarize the route. If I put that is a normally 192.168.130, but it will summarize all these routes as 192.168.100. So these all three routes are like just only the last bit is changed, so it will summarize the route. And another thing is if we can configure as a wildcard also. So if you put the wildcard, it won't summarize the routes. So what summarizing route also I explained that if we summarize the route, it will broadcast everything everywhere in the autonomous system. So that is a thing I'm going to tell you. And recent in a latest EIGRP, you can use a virtual instance name also instead of autonomous number. You can virtual instance name. So there is a two types of things you can use for that EIGRP. Okay. So what we are doing first router is same as router OSPF is a process number in OSPF, but here we call autonomous number is it is from 1 to 65,535. So that is called your router EIGRP, and autonomous number is I'm just using 10 for this one. So you can use the same number for everywhere. You must use this autonomous number. So they will think that they will autonomous is like a area in OSPF. Okay, and network IP address network what we got is 192.168.100. This is 0. First one is 0. The thing is if I don't use any wildcard, it will just take it as a summarized route. Okay, so what I'm doing here, I'm using wildcard 0.0.0. Sorry, too many zeros. 252. You can use this, or you can use. There is a two ways you can use that also. 255, 255, 255.252 at the end. Okay, so that's I'm saying that you can use however you want. Here, sorry, is a three actually is a three. Okay, yeah. Then we're going to do next one. Okay. we're going to do everything on all the routers, same configuration. So I'm going to do network. Here is we got three networks. So 192.168 and 100 dot we got this one is a 4. You can see that here is a 4 network 100.4. So I'm configuring 100.4 and 0.0.0.3. And another network we got is 192.168.100 sorry, we got 1.0. This is 1.0. This is which is connected to PC. Okay, 0.0.0 and 255. We are want to establish the EIGRP network on that PC1. Okay, this this is only the is configuration is simple on EIGRP OSPF, but design consideration totally different. We will go through that next bit. I'm going to configure all the same thing. A router EIGRP, the autonomous number must be same on all the routers, which is the same autonomous. If is you configure into different autonomous, it must be different autonomous number. That is, it is little bit depth into EIGRP, but we are not discussing that here. That is not only CCNA level, that is next level of CCNP or next levels. Okay, so I'm going to do same configuration and EIGRP configuration for all the routers, and I will come back again after some time. Okay guys, here I am configuring on the router 5 now. So I just want to show something here. When we configuring that, it will get the adjacency. It will receive adjacency with the neighbor router. So I want to show something logs. What is the message you will receive when they successfully do that one. Okay. Here is the EIGRP 10. I am doing on router 5 now. Is a network 192.168. We got 112 network on G00. Okay, is 0.0.0.3. Yeah, and another thing is you see that when I neighbor relationship established it with the neighbor dot 13, which is a root of 5 gigabit interface 00. The other side of the IP address is that, and here is a we got 20 here. Okay, 20 networks. That's it. You see that you will receive the message. Okay, that's quick. Yes, you other interface connection on 01 is connected this side. Okay, now I'm saving the configuration. Okay, this is we configure all the interfaces with the IP address, then we configure the our EIGRP router. So we want to check from PC1 to PC2. Before going that, so I want to verify the topology. So how we going to verify this topology? First, this is a basic command we normally use for all the configuration. Show IP root. Okay, this is the root will shows everything. Okay, 192.168.1.0 is 24. This is the PC1 network. It learned via 192.168.100.21, which is this one. This is the one it learned. It first it got the 21. So you see that this is a 21 and then 13 is the other side of that one. So this is the 43. This is the time the 00, and also 192.168.2.0, which is directly connected. And also here is you can see that it is variably subnetted. It is what it did, it summarized all routes and it put the distance vector. Yeah, so you will see more. Okay, here it is 30 100.4. It learned through 100.13 and this one is 100.21. Okay, 0 network is connecting from here, but dot 4 network which is connecting this way. Okay, so this is two different paths there, and dot 8 is also you see that one path. Why is dot 8 is here is the next to this one, so its nearest path is this one, so it kept this one path here. Then 12.30 is the next to that one. Then 14.32 is this one. This is the network, it is connected from this side. So it will kept all the administrative distance and uh, administrative distance and the cost of the network. So it kept everything, every value is here. Okay, so this is the first command we normally checks to do that, verify the stuff. Okay, now another command we will show that what metric weights toss and everything, and also auto sum. If you want to auto summary, I explain that auto summary is there. It is summarize all these routers into single route. So normally in a default auto summary is disabled. Okay, so that is why I'm saying that, that is why it's not summarized, and also we use the wildcard. Okay, and the first thing next we need to check our neighbors. So what is it will do now? First IP show IP EIGRP neighbors. Okay, the router 5 has two neighbors. This one has two neighbors. One is 3 and one is 2. So if you see this one, gigabit 01 and one is a 00. Okay, so this one is our router 3 and this one is router 13. So what you got it from this, all the information is showing here. So it's clearly showing how much distance and show everything what is happening on that network and how much distance from that. What is the next command it will sorry, next interval as a advertisement, it shows that one. Okay, so this is mainly important when you debug, when you troubleshooting the EIGRP, when you're trying to debug or anything. So this is very important one, you need to consider about these things. Okay, then another command I will show you, that another command is data neighbors details. Also it will give you complete neighbor details. Also details means it gives you more information about those things. Topology IDs from peer 0, topology is advertised to peer base topology. Yeah, so this is a little bit more extra information about everything. Okay, and it will show you, next we can show that show IP EIGRP neighbors, EIGH neighbors. Okay, sorry, what is the, yeah, sorry, not neighbors, sorry, interfaces. Next thing we will check interfaces. Okay, this is interfaces where we configure our EIGRP 0001. We configure this, all the EIGRP reliable. These paths are going to these different locations. Okay, we are advertise those things. Okay, and also we can show the EIGRP topology. Yeah, EIGRP topology. Okay, so it gives everything show IP route model, but individually put the individual thing, every router it will give you that one. So you see the P means passive. In the passive interface it won't advertise the route, it won't advertise the advertisements. It only use the active interface to send all the advertisements. So the main thing here it is our active interface here it is this one 01 is our active interface, not the passive interface is that. Okay, so each one you have the passive interface from where it was from where. Yeah, so those are not passives, actives. Okay, so it will help you to troubleshoot that one. And also uh, debugging or debug command, you can debug EIGRP packets, you can debug EIGRP FSMs, and there's a lot of things. And another thing, show IP EIGRP route. Sorry, I missed something. Show IP EIGRP route. Sorry, route EIGRP. Okay, this is same like show IP route. It won't give you any extra information, but it will give you all the administrative distance and other things. Okay, we got everything whatever we got. So now if I check, and from PC1 I would like to show from here now. Okay, if we trace it from here to our PC2 IP address is 192.168. 2.5. Okay, if I do ping 192.168.2.5, this is our IP address is, okay, destination host unreachable. So we will check what is the IP address actually. I configured here. Did I configure the EIGRP on this network? Show IP route. So 2.1 we configured that it is directly connected, and we will check what is happening in here. Okay, console. So here we need that our skills now. Okay, exit, show IP route. We haven't seen route to here. To 196.1.2. Okay, so we haven't seen this route here. So the route to the two network is not advertised in our EIGRP table. Okay, so we will check what is happening. Why is not advertised here? Okay, okay, show IP EIGRP. Okay, what we got? Events, accounting interfaces, neighbors, SAMS, topology. Okay, topology. Okay, why is 840 is there, 20 is there, 20 is directly connected, and 12 is directly connected, but we missed 2. Maybe during the configuration we haven't done that one. Okay, config T. I'm going to IP router EIGRP. Autonomous in number is 10. We will a network 192.168.2.0 okay, that's the one, another one, and we will put those also. Okay, now do show IP EIGRP topology. Okay, here it is 0.04. Now you got the here our network topology is available in our topology. So it's easy to find out how to do that. Now we go into this one. So what is happening with the PC1? 6 is closing. We go into PC1 now. Okay. So now we can reach, and you will see that here also route 6. Okay. Show IP route. Okay. Here is 2. Where is 2? 2. Okay. There is 1. Here is 2. Okay. Administrative distance, and it will thing. Okay. What I'm going to show you now which way we are going from this PC to that PC. Okay. I'm doing tracer. Sorry. What commands we available here? Trace. Yeah. Trace. And we are doing the host 192.168.2.5. Okay, so you will see that it is going to 1.1, then 100.6. So is going through this way. So 100.6, then 18. So that means it is going through this path. Okay, what we will do in this router, yeah, I'm opening this one now. So you will see that in this router, if you see the network going here. Okay, so I want to show something, but we'll see that if I'm able to put this one on top of everything. Sorry, it is not showing that, but I will squeeze this one now a little bit. So okay, we don't need this one, so I can put that one, and we don't need this one also, so you can see a little bit bigger. So what I'm doing, okay, sorry guys. Okay, Here it is. It's a PC1. This is a path. You can see that this is going through this one, and you see that this is a. If I show the show IP topology, show IP EIGRP topology. Okay, you see that this is a path going. This is a PC1 and 2.0 administrative distance 100.2 100.6. So it has two one. This one and this one. Okay, what we'll do? It is present is going this way. So we will remove this link now. So you will see the all the advertisements on the route 6 now. Okay, but I haven't enabled the debug, but still you will see that one. So the path is immediately changed, dual in charge of interface down. So you will see the interface down and 0 1 here. So it will immediately switch to, you see that EIGRP topology now. It will deleted that path immediately. It will establish the path. It is very quick. Is quicker than OSPF. OSPF waits for 40 seconds to tell that it is dead. It will wait for some time. It's allow intervals for 10 seconds and dead intervals for 40 seconds. But EIGRP immediately replicates, advertise everything, and you will see that is a path is different now. Before is 1 1, then is 100.6, but now is going to 100.2 and 100.10. Okay, this is the way it going that one now. Okay, so I we explained everything EIGRP about how to troubleshoot, how to verify the topology and configuration. This is the one we normally discuss. And what another thing, what is going to get in your exam actually? The main questions they will ask you in EIGRP is about router running about the cost. Two different paths. Which parameter does the router use to select the best path? That is about the administrative distance or metric or cost. The main thing is metric. Metric get the priority. Okay, metric is the best. That is you need metric path is important to select the best path. And sometimes route they will ask you so which way it will take the route selection process. Yeah, so which the speed and everything. Yeah, and some of the questions is about the they will give you the, I explained in OSPF class, they will give you the both configuration next to each other in screenshot. If you want to reach this one, what configuration you need to change. So please be careful when you're looking in those configuration. This is just minor changes about the path or metric or something, or they will ask something different. Okay, please be careful when you're doing the question answers in exam. Just watch those configuration, familiar with these verifying commands and show topologies, and some of that is a configuration of the metrics, debugging of other commands. Okay, that's it for this video. Please subscribe for latest updates. If you have any comments or if you have any if you have suggestions, any feedback, please put them in comments below. Thank you very much. Bye. Thank you.